It's a report that's as thrilling as it is unbelievable. New analysis of data from the James Webb Space Telescope suggests that our entire universe might exist inside a black hole. But how could that possibly be? Aren't black holes those terrifying cosmic beasts that destroy everything in their path? Well, not exactly. According to this new research, it's possible that our universe was actually born inside one of these gravitational giants. So, what exactly did the Webb telescope uncover, and what does this discovery mean for our understanding of the cosmos? Stick around to the end to find out if we might really be living inside a black hole. In our day-to-day lives, we encounter all kinds of experiences, whether it's breathtaking landscapes, crowded cityscapes, or even something as simple as the clouds drifting across the sky. Have you ever stopped to wonder where it all began, what the true origin of everything is? From an astronomical perspective, the answer seems fairly well established. Most scientists still support the idea that the universe, along with everything within it, originated from the event we know as the Big Bang. According to this widely accepted theory, space, time, and matter all emerged from an initial singularity around 13.8 billion years ago. But how can we be so confident in this explanation today? The key lies in a fundamental property of the cosmos, its continuous expansion. By observing this expansion and tracing it backward in time, scientists can calculate the moment when the entire universe was compressed into an incredibly small, dense point. It's important to note, however, that the Big Bang theory doesn't actually describe the bang itself. Rather, it explains the evolution of the universe in the moments immediately following that initial event. But stepping outside the realm of theory for a moment, a very different question comes into focus. Is there any real, observable evidence for the Big Bang? It turns out, yes, there is. One of the most compelling pieces of evidence scientists point to is the cosmic microwave background radiation. This nearly uniform, direction-independent glow permeates the entire universe and dates back to around 380,000 years after the Big Bang. Still, even with this radiation as a powerful clue, the Big Bang theory continues to raise some profound and unresolved questions. These questions strike at the very heart of our understanding. How and why did everything begin? What sparked the sudden appearance of something from absolutely nothing 13.8 billion years ago? Is it even possible for anything to emerge out of true nothingness? How did the universe's tiny primordial seed come into existence? Was it triggered by something specific, or was it a random event? The James Webb Space Telescope is pushing the boundaries of our understanding of the cosmos with its groundbreaking discoveries. Not only has it confirmed that the universe is expanding at a rate much faster than current models can explain, but it has also uncovered a collection of unexpectedly large galaxies dating back to the very early stages of the universe. These galaxies, much more massive than anticipated, are forcing scientists to rethink long-standing theories about the universe's evolution. As a result, an increasing number of researchers are revisiting the foundational concepts of cosmology, particularly the Big Bang theory. Some of the most provocative ideas emerging from this shift propose that our universe might not be the only one, or even the true origin of all existence. Instead, there is a growing hypothesis that the universe we observe could be contained within a black hole, suggesting a far more complex and interconnected cosmos than we ever imagined. This possibility challenges the very nature of reality and invites us to reconsider the fundamental laws that govern our universe. And here's the twist: this isn't some far-fetched fringe theory. In fact, it's a possibility that's gaining fresh momentum thanks to recent discoveries by the James Webb Space Telescope. Could we actually be living inside a black hole? At first, the idea sounds completely outrageous. After all, black holes are usually portrayed as cosmic monsters, unstoppable forces that consume everything in their path. But that image only tells part of the story. Yes, black holes can be destructive, but it's also true that celestial bodies can orbit them in stable paths, and more importantly, we still don't fully understand what lies at their core. It's even possible that we witness the hidden center of these mysterious giants more often than we realize. So, what exactly is this fascinating hypothesis? To explore that, We need to look at the research coming out of Kansas State University, led by physicist Lur Shamir. A team of experts conducted an extensive study of 263 early galaxies in the JWST, James Webb Space Telescope Advanced Deep Extragalactic Survey, field, which had been previously observed by NASA's James Webb Space Telescope. The study uncovered an intriguing and unexpected finding. The majority of these galaxies exhibit a uniform rotation pattern. Specifically, around two-thirds of these galaxies rotate in a clockwise direction, while the remaining one-third rotate counterclockwise. This discovery is particularly significant because it defies the expectations set by current models of galaxy rotation. In a random universe, scientists would anticipate an even distribution of rotational directions, with no inherent preference for clockwise or counterclockwise spins. The fact that such an imbalance exists has led researchers to question the underlying causes. To investigate further, scientists at Kansas State University are exploring two possible theories to explain this phenomenon, which could have important implications for our understanding of galaxy formation and evolution. The first theory suggests that the observed phenomenon may simply be the result of measurement errors. It posits that the Doppler effect could cause galaxies moving toward us to appear brighter than those moving away. This could lead to a distortion in measurements, making it seem like more galaxies are present in a specific direction of rotation than actually exist. The second theory, which is particularly fascinating, proposes that our universe originated inside a black hole that already had its own rotation. Scientists argue that this idea aligns with Schwartz cosmology, which suggests that our entire universe exists within the interior of a black hole in a much larger, mother, cosmos. In this view, each black hole serves as a gateway to a baby universe, and the rotation of the original black hole influences the preferred direction of rotation for galaxies in the newly formed universe. Nikodem Poplawski explains, a preferred axis in our universe, inherited from the spin axis of a black hole, may have influenced the rotational dynamics of galaxies, leading to the observed asymmetry between clockwise and counterclockwise rotations. And if anyone is familiar with this subject, it's Nicodemosi. After all, the theoretical physicist at the University of New Haven not only believes we are inside a black hole, but he also seeks to understand how our universe was birthed in the heart of this massive entity, how the primordial seed of our cosmos exploded into existence. While this idea may sound surprising, the notion that our universe resides inside a black hole actually dates back well before recent discoveries on the web. Specifically, the concept was first proposed in the 1970s by Raj Kumar Pathria and Irving John Good, and was later expanded upon by researchers like Nicodemosi. Before delving further into this fascinating theory, let's briefly revisit Einstein's work to better understand what might be happening at the core of a black hole. A singularity, a point that is both infinitely dense and infinitely small, can be theoretically calculated. However, this singularity presents a critical issue: such conditions do not exist in nature. Even though these hypothetical concepts are perfect for decoding much of the universe's mysteries, they encounter their limits when confronted with the immense forces that occur inside phenomena like black holes. This same problem applies to understanding the birth of our universe. According to Poplawski, the matter that a black hole absorbs is compressed to the point where it can no longer shrink. This process creates a cosmic primal seed that, although unimaginably small, differs from a singularity because it is a tangible entity. Poplawski further explains that compression halts because black holes rotate at extraordinary speeds. As they approach near light-speed rotation, immense torsional forces act on the primal seed inside, altering the dynamics of matter in ways that are still not fully understood. These extreme forces may be the key to unlocking new insights into the nature of black holes and the origins of our cosmos. The universe is not just tiny and unimaginably vast, but also compressed and twisted in ways that challenge our understanding. Imagine, if you will, that the seed of our cosmos could metaphorically burst open in a process that cosmologist Poplawski describes not as the Big Bang, but as the Big Bounce. In this view, a black hole could serve as the gateway between two universes, a sort of cosmic threshold that can only be crossed in one direction. If a person were to fall into the heart of a black hole, they might unexpectedly find themselves in a completely different universe, well, at least the fragmented remnants of themselves. Poplawski emphasizes that this alternate cosmos would not exist within our universe.